Hello and welcome to Empowered Learning. This is the second video in the series of videos that discuss how to find the probability of a data value that's chosen. Um, and we're going to do this by looking at our Z-distribution tables and doing linear interpolation to find what the probability will be. Okay. So again, we want to start off just like how we did last time by calculating the Z-score. For those of you that are interested in seeing this done just via calculator, you may want to go to part 1 of this video. Part 2 is just for linear interpolation. So here, find the data value of Z of 18. Here we know that this was the formula from the last video. And when we calculated all this, I'm just going to write through it fast here so that we can get going. We know that this ended up being 1.293, 3, 4, 5, 8, 7, 9, 4. Okay. So we know that what we're trying to do here, we draw this out. We know that if our mean is 0, meaning that if we have this all in terms of Z distribution, then this 0 here is the same thing as this 13.45 with data values. Then here, what we're doing is trying to figure out this particular number here. I'm just going to round it off to that. What is the area under the curve from way over here all the way to this Z-score right here? Okay. So how we do this looking at our Z-distribution chart is that we need to go to it and find out what probability goes along with 1.2934 blah 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 blah, right? And what we're going to find out is that this specific Z-score is not going to be in the table. So what we're going to have to do is sort of figure out what the probability is going to be by using the information that we already have. And so that's where the linear interpolation comes in. So let me move forward here. So this is our Z distribution table, also called a standard normal probability table. And how we read values, and I'm just going to use a random number as an example. So let's say I wanted to figure out what the corresponding probability of the number negative 2.24 is, okay? So here, I split up this number this way. And actually, let me just erase that and use it as a minus. So we split up this number this way because we know that if I take 2.2 and then I add 0.04 to it, that'll be 2.24. And of course, all I'm doing here is just making this negative to make that negative. So here we see that we have a negative 2.2 here, and then the 0.04 column is here. So we look and see where these intersect. And where they intersect is here. So what we're saying is that if, let's say this Z-score here was a negative 2.24, then the area under the curve from all the way down to the leftmost portion of the graph to this is roughly going to be 0.0125. Or if you translate that into percent, roughly about 1.25% of the total area under the curve of this graph here, okay? So that's how we read Z-scores in general. So what we're going to do to figure out the one that we need, we're going to go to the other part of our table here, because as you notice, the Z values that we have here are all negative, okay? And if we keep scrolling down, They're all negative until we get to right before 0. Okay. And so on the next page, I'll have the positive end of the graph. And you'll see that when we do this, you see how this area is on the left side. So you'll see that when we go to the next page, we'll have all of this left area covered plus some of the right. And so that's why in that first video, when we use this function normal CDF, the C part is for cumulative distribution, okay? Meaning that we're adding up the areas as we go from left to right. So on the next page, you can see how we have more of this area here. And again, what we're trying to figure out is what is going to be this particular area under the curve at this data value. And of course, I've rounded this off. We know that this particular z-score has some more decimals, but of course I just rounded out to 4 decimal places. So here, if I look, I know that 1.2935 blah 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 blah. I know that it's in between 1.29 and 1.3. Okay, so when I look here, I have 1.2, and then of course I'll break that up with the 0.29 part. So we look here and here. And you see we have this value here. So a z-score of 1.29. Sorry, I wrote that wrong. So this should be when z is equal to 1.29. That's going to imply that it has a corresponding probability of 0.9015. Okay. If we do the same thing for 1.3, which is here, in particular 1.30, so we use this column, and that maps down to here and here. So that means this goes along with the probability of 0.9032. Okay. So now that we have that information here, what I want you to notice when we do this linear interpolation, what we are assuming here is that since it's such a small distance in between 1.29 and 1.3, that even though we have this probability, density function kind of doing like this, within that small range, this particular function will be acting like a line here. And so to make my point, I'm going to go back to the previous page here, and I'm going to erase some of this so that I can draw a little more so you can get an intuitive understanding of what's going on. All right, so I'm going back to the other page here. I'm going to zoom in on this probability density function here. I'm going to zoom in some more so you can really see what I'm talking about. Do a little more. All right, so if we zoom in, then we're going to act like when we write this number here, this will be like 1.29, and this will be like 1.3 here. And if we map up to here for this point, map up to here, this point, and you can see that this segment that's right here, and I'll move it back. This segment right here roughly looks like a straight line that's going down. And so what we're trying to do is we want to find out what is this actual point that goes along with the data value of 1.29. But the 1.2935 value that we were talking about before. Okay. And so we're going to assume that these 2 points are on a line, and that we're going to try to find basically the corresponding y coordinate for this particular point here. So that's what linear interpolation is about. So to make my point here, this is 1.29, and the corresponding probability for that is going to be this value here. This is 1.3, and this data value is going to be here. Okay. And now here, what we're saying is if we do the 1.29 blah, 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 blah number, what is going to be this corresponding y value? So that's essentially what linear interpolation is about. So we are going to take these 2 points, find out what our slope of our line is, and then after that, we're going to say, hey, if this particular point here is also going to be on this particular line that has the same slope, then what is the corresponding y value? So that's essentially what we're about to do. Okay, so we're going to go back to the very first page, set this up, and then after we do it, then you'll see how we get that corresponding probability value. All right, so now that we kind of understand what linear interpolation is and what our strategy is, of course, first thing that we want to do is find out what is going to be the slope of the line that corresponds to those 2 data values of what the z-score is. We got 1.29, and the z-score is when we have 1.30. So, of course, again, I'll go ahead and write this again. We know that this z-score corresponds to a probability of 0.9015, and this other one corresponds to a probability of 0.9032. And get those looking correct. So, of course, this means that we have the points 1.29, 0.9015 on a graph, and 1.30, 0.9032. Okay. Again, our goal is to be able to find some equation of a line y equals mx plus b that will allow us to be able to plug in this data value into the x value for that equation to get the corresponding y value, which will be this probability. Okay, so of course, to do that, we need to know what the slope is, and of course also the y-intercept. So we're going to focus on the slope first. So the slope of this line is just going to be y2 minus y1 over x2 minus x1. And so, of course, we'll use these points. I'll let this be my x1, y1, and x2, y2. And when we do that, just go ahead and write everything in. When we do this, we'll see that the numerator ends up being 0.0017. Denominator is 0.01. And the answer that we get when we do that is just 0.17. So 17 100ths. So from there, we'll use this slope and one of the 2 points to be able to find out our equation of a line. So here we know that point slope form of equation of a line is this. And since I already have this labeled as x1, y1, I'm going to plug in x1, y1 here and my slope, and then just solve for y. So if we do that, my y1 is just going to be 0.9015. Slope is going to be 0.17. and my x sub 1 is 1.29. And so now to get this in the form of y equals mx plus b, like how we said we wanted before, we just solve this for y. So I'll go ahead and distribute to both terms here. Decimal. And when I do that, I'll just have 0.17x minus, and if I multiply 0.17 times a negative 1.29, I'll get a negative 0.2193. And then of course I'll add this 0.9015 to both sides. And the result is here, once that cancels, that y is equal to 0.17x plus 0.6822. And that is what our equation of a line is. So now at this point, I'm saying when x is equal to, and I'm going to put the exact value here, 1.293458794, okay? And so again, this is the actual z-score that we need to find the actual probability, which is going to be this y value here, okay? So when we know x is this, we're just going to plug in this number into our equation of a line here. And you'll see that when we do the multiplication for the first term, we get 0.219887995. And then, of course, this should be, yeah, okay. And so then, of course, when we add this together, this will be 0.90287995. Okay. And so if you remember, this particular value, it's not the exact same, but it's very close to the data value that we had before whenever we did this via the calculator in the first video. And I'll go ahead and show you that data value here in just a second. All right, so if we look at the calculator here, go ahead and bring that in. You'll see that this was the actual data value that we got when we did it in the first video, part 1. This data value of 0.90207, and you'll see that after about the 4th decimal place, that's where the difference happens. And so the reason for that is just because, of course, we're trying to approximate that normal distribution curve as a line for that small portion of it, and beyond the 4th decimal place, that's where things start to kind of deviate, okay, or be different. So anyway, I hope this helps to give you some perspective on how we actually use the z-distribution charts to be able to find out what our corresponding probabilities are. We also can go backwards and say, hey, for a particular probability, what is going to be the given z-score for that? We can also do that as well. I mean, if you know what the probability is, then you can just backtrack and figure out what the z-score is. And so I'll give you a quick example of that before we finish. I think I've already done it, but I'll do it again. So let's go back here to this graph. So let's say I want something that's going to be a probability of And I'm just going to pick something easy here. So let's say probability of that's equal to 0.9699. Okay, so here we see that 0.9699 is roughly that. That goes along with this column and this row. So of course, this probability would go with a z-score of 1.88. Okay, and then let's say if we wanted to do a probability that is, let's say 90%. So that's like 0.9. Of course, if you look in your chart here, you don't see anything that is directly 90% or 0.9 here. So I'm going to erase this. So again, you don't see anything that's exactly 0.9000, but you do see when we start to look at these data values right along here, we see that somewhere in between here and here is going to be 0.9. And so you know that your data value is going to be in between essentially 1.28 and 1.29. And so you can do the linear interpolation just like how we've done. And instead of actually solving for the y value this time, which would be representative as the probability, you would solve for the x value once you form your equation. Excuse me. And so that would be the only difference in between if you're given a problem that says something about hey, we know that the probability of picking this data value is this. What is the corresponding z-score to that? Okay. And then, of course, from that z-score, you could backtrack and figure out what that actual data value would be. That would say if you pick that data value or less, you would end up having this probability of 90%. Okay. All right, so again, I hope that this particular video helps put some perspective on how to figure out what your probabilities are going to be given information about your data like population mean, population standard deviation, and how we calculate that by hand using these charts. So the next video that I'm going to do will be on how do you actually look at a situation where you have to find the probability that you're going to pick a data value in between two data value sets. So we'll go over that in the next video, and hopefully that'll help you be able to show you again how we use these charts and or your calculator to come up with these values. Thanks so much.